All right. Hello. My name is Brian Brown. I work at Google. I'm an engineering director on Google Maps, and my team focuses on applying machine learning techniques to extract data from different sources like imagery. And I'm joined here today with Rinaldo Maldera, who's actually in our Dublin office. I'm in Boulder, and maybe Rinaldo, you could introduce yourself.
Yeah, as you said, Rinaldo Maldera. I lead one of the data science teams in Google Maps as well. We focus on evaluating data quality, search quality, machine learning pipelines, and kind of a broad spectrum of data science tasks in Google Maps.
Sweet. I was thinking that maybe I should wear my CU Buffs hat for the rest of the interview, or I also have option to wear.
Oh, I should get my Nugler
my
cap
Google
as well.
Nugler hat, but I think I'll pass. Yeah, so I've been at Google now for coming up on 15 years in a couple of weeks actually, and working with data scientists at Google has been fantastic, especially from my background, which I graduated from the University of Colorado in 2000 in architectural engineering, and so my background in statistics and computer science itself was pretty weak. So I rely on experts like Rinaldo to actually understand data much more deeply than my background. But maybe we could just jump in with like, what does data science mean to you, Rinaldo, and maybe at Google specifically, what do people think of as data science?
Yeah, I think that to me, it represents the idea of using all kinds of techniques to kind of get the truth and help people make hopefully the best decision they can with the information that we have available. I think that what is interesting about the idea of data science and the science of it is that a lot of the time you won't have the perfect answer, right? And also, the decision makers need to be agile to move kind of at the same pace that the world is moving. So is how exact, how precise you can be with what you have available, and how can you give them enough so they can make the right decision, and like navigating the complexity of what is good enough versus how precise you can be versus like all the array of techniques that you have available to do that is kind of exciting. And I think at Google, yeah, data science is kind of at the core of a lot of things that we do as a company. So being extremely data driven, ensuring that we have the right way to measure initiatives, to drive initiatives, to create new products that are satisfying users, and that we have the right ways to understand what exactly that means, what exactly it means like to satisfy users, to have the metrics, the models, all the context and the framework that these decision makers need to really know, okay, we are satisfying our users and we are ensuring that these products are meeting their needs. Yeah, data science is at the core of that. So that's why you see, well, data science being applied all over the organization.
That's great. I mean, we always have said that Google's a data-driven company, and you mentioned that. Maybe you could go a little bit deeper into that. Like, what always bugs me is when people say, "Let's do an experiment," and they have no idea like what questions they're actually trying to answer. So when they go into it, because or more they want to just like analyze some data so that they can justify a decision that they've already made. For you, what is it? How do you think data science can help drive decision making, and what's the approach that you take to actually make that work?
Yeah, it's kind of funny that you mentioned those kind of comments, because I think that that's what people rely on. Like, they know that some of the right answers come, that way. Oh, well, like if we do an experiment, like we will know exactly what we need to know, etc. But what is true is that the earlier that our counterparts, like being an engineering lead or a product manager, like they involve data scientists, I guess the best that decision will be, like if we are involved early enough when you are thinking or when they're thinking about the project, we are able to suggest what is the best way to understand the headroom or to understand the opportunity, or to put like those metrics, and even suggest if there is a new product or a new feature, what is the login that needs to be there in advance so we can understand how this product is being used, how to measure and model and experiments in the future when we want to extend this, and when we want to see how it relates and interacts with other products that already exist. And then like something that makes us quite data driven is not only that folks can understand the opportunity using numbers, using metrics, using experiments, but also once something has been implemented, it is very common to, again, like do experiments to see what is the impact on what we thought was going to move, or to confirm that the understanding that we had of our users, of a particular market, of whatever this feature or this product is trying to benefit. People kind of rely on data scientists to tell them, well, yeah, like this is how we see things moving. This was the right hypothesis, and now we are confirming that what we did actually was going to impact this, was going to benefit this, improve this. So it's kind of interesting here, and I love that people go and think about the problem from a data perspective at the beginning, in the middle, and at the end, like before they jump into a new product or a new project. So that's how I see that we are quite data driven. Yeah,
that's cool. So one of the things I mentioned at the beginning was that my team focuses on the applications of machine learning, and you and I have worked together a lot on establishing standards around that for evaluation of performance of models and things like this. How do you think machine learning uniquely as a field relates to data science, especially at Google, where we use machine learning a lot? What are some of the unique aspects of that? What are maybe unique challenges or specific applications where it's been a bit different than just maybe traditional data science?
Yeah, I think I really like and I use this a lot in my presentations, the quote by Cassie Kosirkov. She's on Google Cloud. And she keeps like saying that data scientists are expected to be, expert analysts, statisticians, and applied ML engineers, like all in one, right? And that's kind of what you see, because all in all, like ML is a discipline that requires a lot of data analysis, depending on the algorithm that you're using. If it is a black box thing, you go from understanding what is the data, understanding the parameters, and then see what comes out of the other side, and then go back without necessarily doing traditional engineering in the middle, right? Like you need to do a lot of analysis on the before and after. And obviously, like data scientists can provide a lot of tools in that, what normally is a multifunctional team, to help people understand, the root causes of that performance increase or drop, or what is the best way to do feature engineering, feature selection. Like when we're talking a lot about diff analysis or performance analysis, or what is the best way to create data sets and to like really use what we have in our machine learning toolkit. That's kind of like the value that we provide. I will say that in Google, compared to other areas, definitely the scale is something different. And this is something that if you go to any data science conference, like nowadays, everything is always like big data. Everything is, the data lakes and how to use everything that you have in that data lake. But when it comes to, I guess externally, like using the equivalent of Kubernetes, or like how to really like talk about billions and billions of images, which is something that we've worked together, or reaching like scale that even when we are talking about big data, we are going like above and beyond that. that's an area where it can be very costly to not know how to do that data analysis, how to do that performance analysis, and like even waiting even if you go with samples, even if you apply the best practices to do those quick iterations, the scale that we're talking about makes things like very different and puts a lot of I guess weight on the data scientist's shoulder to like do things right and ensure that they enable the engineers to do the best they can with the tools that they have available. So that's probably what is slightly different at Google compared to other areas, data science and ML. Yeah.
Cool. Maybe a follow on to that then. What does Google actually look for when they're hiring a data scientist? I know that you've hired many and have built some really great teams. What does Google look for in general, and what do you specifically look for when you're hiring?
Yeah, that's an interesting question. So I would say that in general is, I mean, this is going to sound a bit cliche because this is a common thing, like, the unicorn, someone that is an engineer, a statistician, and also a perfect like business context presenter, like all in one, right? And as the whole idea of the unicorn, like that doesn't exist. But obviously, like we want as much as possible someone that is well-rounded, or that if you are incredibly strong in one of those three areas, that you are strong enough that you can, that we know that you will be able to learn about like the other areas, right? So that's probably like what we look for, like to make sure that someone is balanced or that is strong, and that we know that like it's obvious that the person will have not only the capability but also the willingness to learn about the other areas and kind of extend like their own skills. I guess in my case, like personally, that's probably what I look for as well. Something that, if a general tip, I guess, is the idea of knowing how to explain concepts in layman terms. That is a key thing for an analyst when you're working with people that might be as or even more technical than yourself. But at the end, you are at the center of, engineering, statistics, analysis, and a lot of different techniques. And you need to be able to explain stuff to different levels. And I'm not talking about like senior and junior people, but like folks that might not be as technical as you are, but they need information to make right decisions. So that's probably something that I'm always on the lookout for, like someone that actually knows how to translate those complicated ideas into something that is actually, actionable by decision makers.
Cool. Thanks for those tips. So maybe on a day-to-day basis, what do you actually do? Right.
I guess it's a mix. Nowadays is a lot of strategy setting and ensuring that we have a proper metric strategy for particular areas, standards when it comes to like key areas like machine learning implementations. I guess that I still do a lot of what we call individual contributor work. So not only like leading the team, but also myself like implementing new metrics or implementing new ways of modeling some of the problems that we have in our plate. So I guess that on a day-to-day, I probably spend about half a day working on either writing parts of our strategy or writing code or ensuring that we have stuff in place, and half is more meeting with my stakeholders, explaining like some insights that we might have available for them, or understanding like how the information that we provided in the past is driving some of their initiatives and what do they need in the future to continue driving those initiatives as well. So it's kind of a mix there.
Cool. Maybe the last question, where you talked about like being at the beginning and kind of in the middle and the end of the product development life cycle. Yeah. Is it really like that? Like what's where is most of the analysis happening or best happening in the product development life cycle?
I would say the most, I guess, unsurprisingly, is in the middle, right? Like when people need to confirm, the direction they took is the right one, when they need to confirm that some of the hypotheses that we had are like are actually the thing that is happening or not. So that's where a lot of work happens. So probably it will be something like 50% of the time is in the middle, and then 25 and 25. And again, as I was saying, like compared to even other companies where I've worked in the past, you see like those requests coming at the beginning and at the end, and people like trying to make sure that they have all the information about what is happening. But definitely the bulk of the work is in the middle, when people are, like it's no longer design or pie in the sky, but like they're in the middle now implementing the stuff, seeing the changes, having to tweak, having to modify or follow a particular roadmap, and they need more and more information to see how good or bad things are. So that's definitely where the bulk of the work happens.
Cool. Well, I think we're kind of at the end of our time, so I really appreciate you taking the time, and thanks for answering all my questions. Hopefully it was useful for some aspiring data scientists, and thanks a lot.
No, thank you. It was a pleasure.